They're in your phone, in the jets flying right over your head, and even inside the human body. We're talking about a class of materials that are absolutely essential to modern life, but they're almost completely invisible. So today, let's dive into the hidden world of advanced ceramics.
All right, let's start with a little puzzle. What could a smartphone, a jet engine, and a dental implant possibly have in common? I mean, at first glance, you think they have absolutely nothing to do with each other. But believe it or not, they all depend on one remarkable type of material to function. Any guesses what that is?
The answer is ceramics. And I know what you're probably picturing. Pottery, right? Dinner plates, coffee mugs. But the ceramics we're talking about today are a whole other universe compared to what's in your kitchen. To really get it, we kind of have to forget everything we think we know about them.
So what exactly is a ceramic in the technical sense? Well, it's an inorganic, non-metallic material that's created using incredibly high heat. Inorganic just means it doesn't come from living things. Think more like rocks and minerals. And it's that intense heating process that forges them, creating these super strong atomic bonds that unlock all their unique and really powerful properties.
This right here shows you the two different worlds perfectly. On one side, you've got your traditional pottery. It's clay-based, it's beautiful, but we all know it's notoriously brittle. Drop it, and it's game over. But on the other side, you have advanced engineering ceramics. These are built from ultra-pure compounds, made for structural jobs, and they are astonishingly tough. Honestly, the difference is like comparing a paper airplane to a stealth bomber.
So what is it that makes these advanced materials so darn special? Let's get into their superpower properties, the very things that make them so incredibly valuable to engineers.
Okay, so it all comes down to 4 key strengths, and it's all thanks to those super rigid atomic bonds we just talked about. First up, they are incredibly hard. So hard, in fact, that they're used in tools that can literally slice through solid steel. Second, they have extreme thermal stability. This means they can handle temperatures that we just melt most metals. No problem at all. Third, amazing chemical resistance. They don't rust or corrode, which is exactly why they're perfect for things like medical implants. And finally, they are excellent electrical insulators. They just refuse to conduct electricity, a trait that is absolutely crucial for pretty much all modern electronics.
Okay, so now that we know what they can do, let's see how they become engineering's secret weapon. You're about to see just how many of these hidden materials are all around us every single day.
Let's really connect the dots here between those properties and their real-world uses. See, in electronics, that insulating ability is the key for all the tiny capacitors and components in your devices. In mechanical engineering, their incredible hardness gets put to use for ultra-sharp cutting tools and durable bearings that basically never wear out. For high-temperature jobs, their stability lets them line massive industrial furnaces and kilns without breaking a sweat. And in medicine, their chemical resistance means they can be used for dental and bone implants that the human body won't reject. I mean, the range of applications is just mind-blowing.
So the big takeaway here is really crucial. Advanced ceramics aren't just another material on the list. They are a true foundation of our modern world. Understanding them is key to understanding how so much of our current technology is even possible.
And hey, don't just take my word for it. The source material for this whole explainer puts it perfectly, and just so simply stating that ceramics play a vital role in modern engineering. It's not just a supporting material, it's a vital one.
So, when you boil it all down, what's the big takeaway? It's this. From the health of our own bodies with biomedical implants, to the function of the digital devices in our pockets, these advanced ceramics are the unseen, unsung foundation of the high-tech world that we all live in. They are everywhere, making the technology we rely on work. And that leaves us with one final thought to chew on. As our technology keeps pushing new boundaries, in space exploration, in energy, in computing, you just have to wonder, where will these incredible hidden materials pop up next? What new problems are they going to solve? Thanks so much for joining me.